So what you're going to see here when you look at some of your problems in my stat lab is something like this, but there'll be a little icon someplace in the problem. And if you click that, it gives you different options. You could open copy to a clipboard. That's probably what I would recommend. And it opens up like this so that you can copy it and paste it into some other program, like paste it into Statdisk or something like that so that you can use it. So beautiful. There you go. Now, if you're done with your data, then you can hit the clear button over here and get rid of all of it. And what's really cool about Statdisk is this. All the data that you're going to use in terms of the data sets of the book is already programmed into Statdisk. So follow me here, click data sets. We're in the 13th edition of Trail of Stats. Click there. And let's go over to kind of a sentimental favorite for mine. It's all the way down to Old Faithful. So let's click Old Faithful. What is Old Faithful? Can someone tell me?
It's in Yellowstone, right?
The Geyser?
In Yellowstone, yeah, it's a geyser. So let's pull up Old Faithful Geyser so people can have a quick look at it. Old Faithful Geyser. There we go. Let's just take kind of a quick look at it. I was there a couple summers ago with my family. It was pretty cool. Got to see a nice eruption. It's nature's show. I mean, if you go to Las Vegas and you stand outside of the Bellagio casino, they got these wonderful fountains that dance around. But this one happens in nature. About every 90 minutes or so, you get this nice eruption of super hot water steaming up 150 feet or so high, and the eruptions last for around 4 minutes. It's just really cool. If you get a chance to visit Yellowstone at all, take it. It's just sumptuously beautiful. Really is. So, all right, that's enough from Yellowstone there. Let me get back to what we're going to do, which is work with that data. Now, there are ways in Excel and Google Sheets to create a frequency distribution. That's what we just looked at. That's just telling you, all right, how many numbers are in each category, or if you want to turn it into percentages, that's fine as well. Both of them work. Both of them tell you some things about your data that are good to know. By the way, do I have it for males? No, I don't. I think the same data for males shows that men are more likely to win it in their 40s, and very few, I think maybe one male won Best Actor in his 20s. So something going on there, but it's not for me as a stat instructor to decide or comment on that. Let's go back here. Has everyone got this data set? We could create a frequency histogram for this, but we're going to do a little bit better. So I'm assuming that everyone's up to speed on this, has the data there. Click the data button then, not the data sets, but the data button, and scroll down to histogram. So underneath data, scroll down to histogram, and then select that. It's going to ask you what column your data is in. Well, we want duration. How long does this eruption typically last? So we'll select that. Then we'll just let the software do the rest. So let's press plot. And you should be getting something like that. So I need some feedback here. Are you guys able to match this calculation?
Yeah.
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 Cool. Now what's
That's the
even
last
nice,
part. I'm sorry. I just want the last part.
the column. I
Mm,
mean the shape.
the shape?
I did everything until the last thing. Just this one.
Okay, so
So I just share the screen, so it's gone when I try to do it. Like your screen is gone. I'm sorry.
okay, so are you in Statdisk?
Yes, I did everything until this one. I didn't. I
Okay.
even did the histogram column, but the last one.
So you go down to histogram,
I did that.
it pulls this up. So the column you need to choose, you do it here, selected column. You want to
I did
scroll
this.
down
Yep, this
to
birthday did it.
duration
Uh-huh.
and then press plot at the
Oh,
bottom.
this is the one. Thank you. Thanks.
Off one.
Got it.
All right. So it should give you something like this. And what you'll notice is that in addition to finding out, where these things are happening in terms of the duration, there's these nice bars here. These bars are drawn commensurate with the height or frequencies of each category. And as you roll over this with your cursor, you should see a few things. Up at the top here, I'm seeing that there was 41 eruptions that lasted between 220 and 229 seconds. What seems like the most typical interval for your eruptions?
240 to 249 seconds.
Yeah, somewhere in here, 240 to 249 seconds. So really, this is better than a frequency histogram because, or better than a frequency distribution, because in addition to the numbers, you're also seeing it visually. And what I see visually is that there's two different types of eruptions. There's one down here in which visitors feel really ripped off, and the other one up here in which you get a good show lasting around 4 minutes. When I was there with my family a few years ago, the first eruption we saw was kind of like this. It's like, really, that's it? And so I knew that, hey, you know what? The typical eruption is more like 4 minutes. So we waited around for another hour and a half. We saw a really good eruption. So it was kind of cool. Let's play with this a little bit because there's some things you can do with frequencies in terms of frequency histograms and frequency distributions that will change its appearance. So start by clicking user defined. And let's do this. Our class width. Can anyone tell me what my class width is now for these histograms? How wide are these classes? This is a good review question.
Is it 10?
Katarina's saying 10. Do you agree with her?
I agree with that.
All right.
I think it's 9.
Thank you, Mason. Thank you. All right. So if you remember from section 2.1, I said it was the difference between adjacent upper and lower class boundaries. So looking here, this is 220 to 229. Let's go with the lower class boundary, which is 220. And then the adjacent one, which is 210. 220 minus 210, that gives you a class width of 10. So that's what we have right here. So let's think of a different number. Something else we can use. Anything? Suggestions? How about 25? What's going to happen when we make these a lot wider? Well, it's going to lump all your data into fewer and fewer categories. Let's take a look at what happens to the shape here. There you go. So all that data that was here now just gets lumped into 3 categories. And maybe that's summarizing things too much. On the other extreme, I could say, all right, let's let the class width be 2. And because we have enough data, this isn't too bad, but sometimes that would spread things out too much. So you want to try and find a happy medium in terms of the number of classes. Now the book actually has some thoughts on that. Trying to find that here. Here we go. Select the number of classes, typically between 5 and 20, somewhere in there. I mean, too few, and you're summarizing everything into just a couple of categories, and it's too much, too many, and it just gets kind of confusing. And once you settle on the number of classes, then you can determine the class width by dividing the range of your data, that is the maximum minus the minimum, divided by the number of classes. That'll give you your class width. You want to take that number, maybe round it to something friendly like 10 or 20 or 25 or 50, something like that, just for convenience of you and people who are going to view this. You don't want your classes to be 7.35 wide. That's just kind of a weird number. I mean, maybe you can justify stuff like that from time to time, but, you know, try and be considerate of people who are going to view your work. And rounding to get a convenient number is good as well. So there's a lot of things. You can find this in the book. I'm trying to think where it is. It's in section 2.1. This is procedure for constructing a frequency distribution. Let me go back. Let me put that up here at 10 again, except this time I'm going to start my classes not at 100, but at 200. Now, what's going to be the effect of starting things at 200? What do you think? Am I going to see this data anymore?
No.
No. And maybe I don't want to. Maybe I'm like, you know what? Let's just focus on the typical eruptions. So there you go. And again, you can play around with this as much as you want. You can make that 15. You can make it 20. Whatever works. As before, you can roll around on this. You can see the frequencies, and you can see the class boundaries. It's pretty nice. Now, currently, this scale goes from 0 to 90. So this should be a little bit less than 90 when I get over to it. There you go, 88. But how about if I change this to relative frequency? Well, didn't really, let's see. I guess I got to pick plot. When I do that, it changes things on the left-hand side. What's this scale represent now? Can anyone tell me? It's percentage. It's what percentage of the data was in this category, 230 to 244 seconds. Oh, and about 38% of the time, you're going to get an eruption that long. Nice. It's just great that all this information is so easily accessible. How are we looking on that one? Doing all right? Now, the shape of this distribution is of interest as well. So let's talk about that for a little bit. And let me go over to here. There's different types of shapes that you can get when you look at your frequency histograms. So the one we often like to see is this one. And that's got kind of like a bell shape. Now, outside of statistics class, you'll probably hear it called a bell distribution or a bell-shaped distribution. But inside of statistics class, it's called a normal distribution. So quite often, we're looking to see if we have a normal distribution. If we do, great. If we don't, okay. You know, sometimes we can't have a normal distribution. But things that are normally distributed are very, very common. Height. The height of men and women have a normal distribution. They're different shapes for men and women, but they're both, you know, about normal. That is, you have a high concentration of people, of men that are around 5'9", women that are around 5'4", etc. And then it tails off. You know, you have fewer and fewer people that are up here, and fewer and fewer people that are out here. Okay. So that's one distribution. It's a very important, a very common one. How about this one over here? Aren't these kind of looking the same? I mean, you call this like the clone family almost, right? They're all the same. They're all, in other words, uniform. So uniform distribution means that all these histograms are about the same. These bars are about the same height, indicating that you're equally likely to land up in any of these categories. There's a couple other things that we could see. Sometimes you get something that kind of looks like a normal distribution, but one side or the other stretches out a little bit farther. And that extra stretch is called the tail. So here it's off to the right. With this other distribution, it's off to the left. And where the tail is, that's the direction that it's skewed. So this is a distribution that's skewed to the right. This is a distribution that's skewed to the left. Okay. So a couple things that are good to know. A couple things that are going to be, that you might be quizzed on. Now, understanding whether or not you have a normal distribution is kind of on the important side. So there's a couple ways you can look and try and decide objectively whether or not something has a normal shape. The first line of defense for you is going to be looking at a histogram. Does it look like it's a normal distribution? Clearly, the one in the upper right-hand corner doesn't. These two, well, it probably takes a little bit to get used to looking at this and saying, all right, that's skewed left or that's skewed right. But one objective way to decide if it's skewed left or skewed right is called a normal quantile plot. So let's look at those. And I'm going to refer you to a page in the book. And it's on page 54 in the book. So let me jump over to there. It's page 54. We're going to go over normal quantile plots again later in the course, just because they're pretty important. What you're going to do with a normal quantile plot is take your data and create this kind of specialized scatter plot. And I'm not going to discuss exactly how it's created. We just have to be able to look at it and say, okay, this is a normal distribution or not. Now this green line here is what you got to target. And what you'd like to see is that your data is randomly scattered around this line. And this one doesn't look too bad. It's not that great. It's not that bad. It'd be nice if we had more data. We could make a better decision. But it looks like it could be normal. Now, if I'm sounding like I'm doing a little waffling and that I'm not really being nice and clear, it's because there's a little bit of an art to deciding if something is a normal distribution just based on a QQ plot or a normal quantile plot. So I'm not really going to give you anything that's, borderline. If I give you something on an exam, it's going to be obviously yes or obviously no. What do I mean by that? Let's take a look at this one. Take a look at the data here. Is that nice and evenly and randomly scattered around this line?
No.
No.
No, it's certainly not. All right, this one's a mess. I have no idea what that distribution would look like, but it certainly wouldn't be a normal distribution. Now here's where I said, I'm not going to try and trick you, and I won't. What do you think about this one? Does that one look like a normal distribution?
Yeah.
It looks pretty good. The unfortunate part about this one is that it has kind of a pattern. It's below the line, then above, then below. It actually looks like a gentle little wave through this green line, doesn't it? And that probably reflects a uniform distribution here. So, I mean, this is not something that I would typically put on a test because I don't expect you to be able to interpret these that well. Basically, you should be able to say, yeah, that one's not. And if it's somewhat close, then there's other objective measures we're going to learn later in this course that can help you decide. But at the very least, you should be able to tell when something's not a normal distribution. Or maybe it's a little bit better and it's like, yeah, okay, that could be a normal distribution. So let's do a couple of example problems like this from the homework. And I think I got to jump over a couple pages. I think it's on page 57. Let me just double check here. Yeah, page 57. So let's look at a few examples of normal quantile plots. By the way, unless you've picked up on it, let me be very clear. Sometimes I call them QQ plots, but normal quantile plots is what they're called here. What do you think for this first one? Is that distributed normally?
Looks fairly normal.
Yeah, I think so.
Okay.
It looks like it has a pattern.
It does look like it have a little bit of a pattern. And because of that pattern, even though this is nice and close to the line, because of that pattern, I'd probably say not. But again, this is not something that I would put on an exam because, you know, it's a little bit subjective. Let's do one that's a little bit more clear here. How about problem number B?
No, not.
No.
No.
Got a couple for no and a definitely no. Yeah, I agree with it. It's clearly not, it's not coming close to that line at all. So no, that one's not from a normal distribution. How about part C?
Yeah. Yes.
All right. So a yes there. Good. I agree with that. Now, when you look here, I mean, some of these are above, some are below, but there's no real pattern to it. And it does somewhat closely follow that line. So you feel pretty good about this. This one looks like a little bit of an outlier, but you can tolerate one outlier in a data set. Probably shouldn't have two. Last one, D. What do you think about D?
No.
Yeah.
No.
Oh no.
No.
Yeah, this one kind of suffering from the same problem that A did, right? That it's up and down and up again, except it's even more accentuated. So yeah, I don't like this one. It's got a little bit of a pattern to it that would make me nervous. So in any case, it's something to be aware of is the normal quantile plots here that, you know, help you start to decide whether or not something has a normal shape. Because as you're going to see as we move on into this course, the normal shape is really important for statistics. We like it when we have normally distributed data. We can work with things when we don't, but it's optimal when we have normally distributed data. So recognizing that is important. All right, any other comments or thoughts on section 2.2 there? All right, I'm going to stop this here and we'll post it.